So when we talk about scale factors, what is a scale factor is the first example. So in real life, whenever people kind of draw designs for things like buildings and planes, etc., obviously they don't draw the exact size of the building, right? Because that'd be ridiculous. Instead, what they do is they draw a scale model. So for example, let's say if we're going to build a building that's 100 meters tall, I might draw something that's 100 times smaller, but then all I have to do is multiply all of the sides by 100 in order to get the actual full size of the building. So whenever we talk about things that are mathematically similar, it means all of the sides have been multiplied by the same number to go from this triangle to this triangle, and also vice versa. So all three of these sides have been multiplied by the same number to go from the left triangle to the right triangle, and again the same for the vice versa. And that number is called a scale factor. It's how many times bigger or smaller one object is compared to another. So again, with the kind of building design, if a building is 100 meters tall, you might draw something that's only 50 centimeters tall, in which case it's going to be 200 times smaller. Or in other words, to go from the design to the real thing, you multiply by 200. That's the scale factor. So when they say in these questions, the two triangles ABC and PO are mathematically similar, it just means that there is a number you times the sides by on this triangle in order to get the other triangle. So how do you work out the missing lengths? Well, the first thing you need to do in any scale factor question is work out what this scale factor is. This is the most important thing. And the way you do that is you look for the two sides that are corresponding. So for example, AB and PQ are the same side on each of the triangle, right? So they're the bottom length. The other triangles, the other sides, for example, CA is the same as the length RP, and CB is the same as the length RQ. All you need is for one of those pairs of sides to have both of the numbers, and then you can work out the scale factor by simply dividing the numbers by each other. So we can do 12 divided by 8, which is 1.5. So in other words, to go from the smaller triangle to the bigger triangle, we times by 1.5. To go from the bigger triangle to the smaller triangle, we divide by 1.5. So if we wanted to work out the side RP, let's call that X for example, all we would need to do is take the corresponding side on this triangle and multiply it by 1.5. So X would just be equal to 26 times 1.5, which if you type it on your calculator should give you 39. Likewise, if we wanted to work out the side on the smaller triangle, all we'd need to do is, because we're going from a bigger to a smaller size, we're going to divide. And again, you can use a bit of common sense here, right? If you know that the left triangle is smaller than the right, then if you're going from right to left, the number should get smaller. And if you're going from left to right, the number should get bigger. So for triangle Y, we're just going to take 45 and divide it by 1.5, because again, to go from the left to the right, we've done y times 1.5 to get 45. So to go backwards, we do 45 divided by 1.5, which is 30. So the length RP is 39 centimeters and the length CB is 30 centimeters. So let's get into a few more questions and see if you can practice it. But here are the main steps. 1, find the scale factor by dividing the two corresponding sides. Then 2, decide if you're going to multiply or divide. But let's have a look at another question. So here again, in the question, they have to tell you if it's similar or mathematically similar or something along those lines. That way we know that it is indeed a scale factor between them. Do you remember what the first step was? We need to work out what the scale factor is. And how do we work out the scale factor? We look for the corresponding sides. So for example, AB and DE are corresponding, but we don't have the length AB, we only have the length DE. So let's see. AC and DF are corresponding, and we have both of the sides. So all we're going to do is we're going to divide those two numbers to get a scale factor of 4. This means to go from the smaller triangle to the bigger one, we're timesing by 4. To go from the bigger to the smaller, we're dividing by 4. So let's say we wanted to work out the length of E to F. Well, we're going from a smaller shape to the bigger shape, so that means X is just going to be equal to 4 multiplied by the scale factor, which is also 4, so 16 centimeters. And let's say we wanted to work out the side AB as well. Well, we're going from a bigger shape to a smaller shape, so that means we're going to divide by the scale factor instead. So divide by 4, which gives me, 5.5? Like that. So the next one, I want you to try and pause the video and see if you can work out how to do it here, because this is the slightly harder example. Now, with this question, the reason why it's a bit harder is it doesn't look like there are two triangles, but there are. the two triangles are like this, and this is my first step when I do this. If it's a bit hard to read, I separate the two triangles. So the first triangle we have is the triangle DEB. That's the first triangle that we have. And we can label up the sides. So over here it says DE is 2 and DB is 6. And we don't know the third length, although we could use Pythagoras to work it out. And the other triangle is ABC, so the overall shape. So I'm going to draw that slightly bigger. And we have A, B, C. Do we know any of those lengths? Well, let's have a look. We have AD, which it doesn't help us exactly, so to speak, because it's only part of the length. And we have DB is 6, so if we label that on here, that means the length A to B should be 15, right? It should be 9 plus 6. And do we have anything else? No, so we've labelled all three of the sides we have. And it says to work out the length C to B, which is this bottom side here. Now remember, what's the first thing we do after we've drawn these triangles? Well, in the previous questions, we worked out the scale factor first because the triangles were already separate. In this case, the triangles were together. So the first step was we separated the triangles, and now we need to work out the scale factor. And once again, we need to look for a corresponding side. So a side that is the same in both. And we have DE here, we don't have AC here. So what we're going to do is we're going to use DB and AB. So the scale factor is 15 over 6, which we can simplify a bit by dividing by 3, which gives us 5 over 2, which is 2.5. So to go from the smaller shape to the bigger shape, we times by 2.5. Now it says we need to work out C to B. The problem is we don't actually know what B to E is. But again, these are right angled triangles, so why don't we just use Pythagoras by doing 6 squared minus 2 squared. This is because we have the hypotenuse and we want the other side, so we're going to square root, do the hypotenuse minus the other side. So square root 6 squared minus 2 squared gives me 4 root 2. Let's leave it as that for now. Which means to go to the bigger shape, we need to take that number and we need to do 4 root 2 times 2.5. So we're going to do answer times 2.5. And it says give it to 2 decimal places. So that gives me 14.14 centimeters. So again, sometimes you are expected to be able to separate the triangles out. So let's see what we have next.